In this video, we are going to talk about frictional force. Frictional force is a force that resists the relative motion between two surfaces. You can have two surfaces. So when you see these two surfaces, there is a surface of the object above and there is a support. Now, these two surfaces are held by a certain force called normal force. Whenever we see surfaces with the help of magnifying glasses, even there looks to be smooth with naked eye, there are irregularities. These are the irregularities between two surfaces. Those are looks to be um, smooth when you see them on naked eye. So there are different cases to consider friction because friction is proportional to a force called the normal force. Frictional force is represented by small f. So this frictional force increases as the force that holds two surfaces together perpendicularly increases. For example, you have two surfaces here. There is one surface here and another surface is acting on it. The force holding these two surfaces perpendicularly is called the normal force. A normal force is a force that holds the surfaces tending to slide together perpendicularly. Now, there are different cases for calculating the normal force. Sometimes it's difficult to calculate the normal force than calculating the frictional force. If the surfaces are exchanging a force like this, and the normal force is equal to the weight. And the frictional force is directly proportional to the normal force, meaning frictional force is directly proportional to the normal force. So meaning the frictional force is the constant called coefficient of friction times the normal force. So this holds all the time, but the normal force depends the way how forces are acting on masses. In this case, for example, the normal force is exactly is equal to the weight mass times gravity. Then the normal force is this amount, and the frictional force is the coefficient of friction times the normal force. So this times the coefficient of friction is mu, and the normal force is the weight, because the only force holding the two surfaces together perpendicularly is the weight of the above mass. So the frictional force is mu times mass times gravity, because the normal force is the mass times gravity. The second case, this is case B, and the above one is case A. This is case A. So in the case of this one, we are going to talk about the normal force, the frictional force, the net force, and the acceleration. This time, the normal force is the force that holds two surfaces together perpendicularly like this. So in this time, the force that holds the surfaces together is only the weight of the above mass, meaning the normal force is equal to, again, the weight, mass times gravity. This is one important thing to note. And the frictional force is defined as mu times the normal force. The force that holds the two surfaces together is the normal force, as we have already mentioned. Now, once we have the frictional force, when you think about the resultant force acting on this mass, okay, the resultant force acting on this mass, the applied force minus the frictional force. The direction of motion is assumed to be like this because of this force. Now, how do we calculate the resultant force? The resultant force is equal to the applied force F minus the frictional force. But the frictional force is mu times the normal force, or mu times the weight. So the resultant force this time is the applied force minus the frictional force mu times the weight. So this is how you calculate the resultant force in the case like this one, in the case like B. The next is, how do we calculate the acceleration? According to Newton's second law, you guys have this triangle. The triangle is the resultant force is here, and the mass is here, and the acceleration is here. You can see the acceleration is always the mass, the resultant force divided by the mass. After you calculate the resultant force as F minus the normal force, I mean the frictional force. So you can do the acceleration as, so the acceleration is the resultant force divided by mass. But the resultant force is already calculated using this equation. The other case is whenever you have a force inclined at an angle, a pulling force. This is the force. So you can see the force, the white represented by the white line, is resolved into this Fx and Fy. Now Fy is tending to detach the surfaces, but there is a weight downward. This time the normal force is equal to the attaching force, the mg, minus the detaching force, the Fy. Then the frictional force is calculated as mu times the normal force, but the normal force is like this. So the frictional force is gonna be mu times, instead of Fn, I'm using mg minus Fy. This is how you calculate the frictional force. Now the second thing to calculate is the net force, the resultant force. So Fx is tending to move the mass in this direction. This is the direction of the acceleration, but the friction is resisting this way. Now, how do we get the resultant force? So the resultant force is calculated as the resultant force is calculated as Fr is equal to the x component of this force, Fx, minus the resisting force of the friction. Remember, the friction is calculated by using this formula. So you can say Fr is equal to Fx minus the mu into mg, the weight, minus the y component of the force. Once you calculate the net force, the acceleration is the F resultant divided by the mass. This is how you do for the cases like this one. Case is the force acting like this one. Now we have another case here. This time a pushing force is acting on the mass, but the weight is downward. This is the weight is attaching force, and it is mass times gravity. And again, the y component of this force is attaching, and the x component is in this direction. So the direction of motion is this way, and the resisting force friction is acting in the other way. Yeah. Now, how do you calculate the normal force? Now, the normal force is, this time, always remember, normal force is a force that attaches the two surfaces. So the sum of the mg, the weight, and the Fy are attaching the surfaces. Because as we have already mentioned earlier, the normal force is a force that attaches the surfaces perpendicularly. So the frictional force is always mu times the normal force. And this is mu times the mg plus Fy. So now you have the expression for the frictional force. And now the next thing to calculate is the resultant force. The resultant force is how much? The resultant force is the Fx, this force, minus the frictional force, because friction always resists your motion. So the Fx minus the frictional force is the resultant force. We have expression for the frictional force here. Now, once you get the resultant force, according to Newton's second law, the acceleration is the resultant force divided by the mass. There's another situation here. Now, there is a mass on a ramp inclined by an angle theta. This time, you are going to have a component of the weight. I'm gonna draw the weight again here. So the weight is something like this vertical, and the vertical weight is resolved as this way. This is the downward force, this force. So this is the mg times the cosine of theta, because if this angle is theta, this is also theta. As the horizontal line rotates by theta, the vertical line also rotates by the same theta. And the y component, the other component of the weight is this one. This is the angle theta. This is the theta. Now, how do you calculate the normal force this time? The normal force is the resultant force. I mean, the normal force is the force that holds the two surfaces together, because this mass is tending to slide and there is a weight pressing the surface downward, and the normal force this time is equal to the mass, the cosine component of the weight, mg cos theta. So once you get the normal force, the frictional force always resists this motion, as we have already mentioned. There are two possibilities. This mass may be sliding down by its own component of the other component of weight, which is the sine component of the weight downward. Or third force may be applied upward, but this time there is no force given acting on this mass, but there is a downward component of the weight. So the frictional force is the coefficient of friction times times the cosine component of the weight. So because the normal force is the frictional force is written as F times the normal force. Now we have the frictional force is mu times mass times gravity times the cosine of the angle. This is how you calculate the frictional force on such a ramp. Now in this ramp, we have what? We have a sliding force downward, which is the sine component of the sine component of the weight. Now a friction gonna be appearing like this. The friction is resisting the motion, because if the direction of acceleration is downward like this, then the friction is going to be like this, upward direction. So now how do we get the resultant force, the downward force? Now our assumption is the mass is sliding down due to this angle theta. So the downward force is the sine component of the weight minus the friction is going to give you the resultant force, because there are two forces acting on this mass. One is the friction resisting the motion, and the other is the sine component of the weight driving the mass to down to the slope. Now this is the expression for the resultant force. But we know frictional force is mu times normal force. The normal force is the cosine component of the weight. So the resultant force this time is equal to mg sine theta minus mu times mg cos theta. Okay. So this can be written as the resultant force is equal to, you can take mg common. So mg is here, and the sine theta plus mu times cos theta. So this is the expression for resultant force. And the acceleration is how much? It is the resultant force divided by the mass. But the resultant force is given by this expression. So the acceleration is mg into the sine theta plus the coefficient of friction times the cos theta divided by the mass. Now the mass can be cancelled. So the expression for the acceleration this time is g times the sine theta plus the coefficient of friction times cosine theta. This is the expression for the acceleration in the case of a ramp sliding down without the application of any force. This case. Thank you for watching this video. If you like the video,